Okay, I'm just going to briefly talk about volume problems. So those are kind of homework problem where they just ask you to find the volume of something, because volume is one of the basic applications of double integrals. You can answer the question of how much. And at how much, it comes from evaluating some double integral. So let's just volume bounded by 4 surfaces. X plus 2y plus z equals 2, they'll give you some equation defining the surface. And they might give you another surface like a plane. So x equals 2y, so it's some plane. Right, because it can also go up in z. So if you have some line, x equals 2y in the coordinate plane, it turns out this has non-zero z values. Right, so that's a plane. And then they might also say in the first octant. Or they might say the plane x equals 0. Right, so we'll do this one. We'll do the x equals 0 case. Really, because what the first octant means is that it just means x is greater than 0, y is greater than 0, and z is greater than 0. So it's a kind of similar idea. So this kind of does not look like an integral problem. So you need to reframe into the double integral setting. And so that means you need a region and you need a function to integrate. Okay, so let's start with A. This is, I think, the hardest part. Actually, let's start with B, because B is the easiest part. Well, B is just going to be x plus 2y plus z equals 2. Z, your f will be determined by z. So you just solve for z. So f of x, y is z, so it's 2 minus x plus 2y. Okay, so that part's easy. So the real question is, how do you find the region? Oh, and by the way, I mean, this was the only thing that it could have been, right? Because if I tried to use x equals 2y to find my z, this doesn't work, right? Because if we go over here, we see it's multi-valued. So you can't integrate that thing. And x equals 0 has the same problem. Right? So this was the only good information that we could have used, right? So now let's return to finding the region. Well, let's start by just draw the non-z stuff. Okay, so if you draw the non-z stuff, so we have x equals 2y, and we have x equals 0. These are the things that do not involve z. So here's x equals 0, and x equals 2y, it will be this line here. Otherwise known as y equals x over 2. Okay. Oh, my bad. That is definitely not x equals 0. That is definitely not x equals 0. What I just drew was y equals 0. We could have done that, but let's just stick to the original problem. Okay, here's x equals 0. Now, we are missing the third boundary. So we need the last boundary of the region. And like it's something that should close up this gap here. Okay? So there's only one more piece of information. So I'm going to use the last information in the problem, and that comes from the x plus 2y plus z equals 2 information. And yeah, I think we actually need that first octant information also. So if we use the first octant, then that means x is greater than 0. So that's okay, right? Our boundaries certainly encapsulate x equal greater than 0 and y greater than 0. But the missing portion is z greater than 0. And so that's the thing here. We need z greater than or equal to 0. So again, let's solve for z and plug that in. Here's the missing condition. And z is 2 minus x minus 2y. So what did I do here? I plugged the first octant info into the z equation. Okay, and so the boundary is now the case z equals 0. So if we return back, it's 2 minus x minus 2y. So it's this line. So line y equals, looks like 1 minus x over 2. So let's just redraw what we have for our region. Here's x equals 0, which I'm going to draw correctly this time. And here's our first line. This was y equals x over 2. And this is x equals 0. And our final line, it starts at 1 when x equals 0. And it'll go down at a slow speed. So that's x over 2. Okay? Really, this should be 1/2. But so now we have our region. Okay? So it's a type 1 region, right? Because if we call this G2 and G1, our G2 is 1 minus x over 2, as we just saw, and our G1 is x over 2. So now we can do our double integral of z, otherwise known as f of xy. Okay, and this part is, the rest is routine. But the setup is the hard part. So that was the point of this video.